Now we are going to start with the health and safety assessment of risks in workplaces for workers, and in particular for the chemical risks. I think that this is, let's say, the most important risks that can happen, especially for the health, but also for the safety, and we can see both of these aspects, especially for our research project for BIOnTop, but also for other projects that can be in with a specific chemical agent that can, let's say, be responsible for a different risks that is in your company as usual, just to be provided due to the specific research that you are going on. So from this list, I'd like to ask you, and you can write in the chat, if you are interested in other specific risks, not only for this list, but also for the previous list in general, for the safety aspects, and also for the general risk that we can have. So we can detail the risk that you are interested in the next webinar meeting, and then I can provide you several information for what you are interested to. So starting from the identification, we say that the identification step is the preliminary, just to understand if there is a chemical risk within your company, within your research project, and so on. We need to identify which are the substances that are used for the chemical aspects. So in the past, we had the Directive 67548, and from 2008, we have a new regulation that needed to harmonize the global system for the classification and labeling of chemical. This is important for, especially for market experts, for let's say, the distribution of all the chemical agents in the world. Since before we had several kinds of, let's say, classification and labeling of chemical agents. In some countries, components, chemical components was, let's say, not toxic, and was very toxic in another ones. So it was very difficult to understand the risks with the, for example, the manipulation, the usage, and so on of a chemical components worldwide. So we needed to understand that this new regulation has defined and important, harmonized all these classification for the chemicals. In particular, this globally harmonized system for the classification and labeling of chemicals provided the information on physical hazards, chemical hazard, the toxicity, also toward the environment, for example, not only for the human health, allowing the unique definition of these characteristics for each specific chemical. So this is important, very important, since we need to understand in one only way which are the characteristics of danger for the workers. So thanks to the globally harmonized system, we had defined the classification, the label, and the safety data sheet with the new symbols, as you see in the picture, but also with just a harmonized way for the definition of these characteristics. And especially for the hazard classification, they are mainly divided in 3 different hazards. So the physical one, the hazard for the human health, and for the environment. These are subsequently divided in several classes. Here you have all the list for these hazards, and you can see that several substances can be in the first class, in the first group, sorry, or in the second, or all the 3 groups. So, for example, you can have the material that is flammable liquids, but also irritation for skin and hazardous for environment and so on. But these classes are used in all the world. And this is the division of these symbols in terms of physical hazards for the human health and for the environment. You can see them, I think, in all the vessels that you have in your lab. I don't know if you still have several, here we are, symbols as the orange one, the hazard symbols that were provided before the globally harmonized system entered in force. So, for example, you have the toxic or the flammable with the fire and so on. But now we have all, if you see my mouse, all the symbols that are in this column for the new GHS system, and the correspondence between the old one and the new one. The only, let's say, new symbol is for the gas under pressure that you can see in the bottom of the slides, but all the other are, let's say, well referred to the previous classification and labeling of the agents, the chemical agents. So just to define them, we have the symbol, the first one for the oxidizers, then the flammable, which let's say collect all the flammable characteristics, both from liquid and for gas agents. We have the explosives, we have the acutely toxic, we have the corrosive for all the surface, both for skin, but also for metals or what else. We have the gases under pressure. We have the carcinogen, respiratory sensitizers, reproductive toxicity, and so on. We have the toxic to aquatic environment, or towards the environment in general. And we have the acutely toxic or irritant to skin that is, let's say, less toxic than the severe acutely toxic one. All this information for the chemical risks are provided in the material safety data sheets. These data sheets are very, very important since they are the identity cards of all the substances and preparations, and they need to be provided according to what was defined in the CLP regulation, classification, labeling, and packaging regulation. It's important that they need to be kept inside the plant or the room or in the area where these substances are used. They have to be taken ready for any consultation, any possible, let's say, check of the information that they are inside. We need to it's important to consult them before using the product, before storing the product, since we have also the information for the storage, the right storage of this product, before the disposal, since we have the information also for the disposal of the residual of this chemical substance, and before the transportation. But it's important, and all the producers need to provide you these safety data sheets before you buy them. So you can ask to your supplier about the safety data sheets. You can find them on the website, but it's important that for each producer you have the specific material safety data sheets that define and describe all the information for the specific chemical you are going to buy or you are buying. So let's have a look at all the 16 paragraphs that are inside, since they are very, very important where we can find the information that we need for the health and safety. So the first 2 points, the identification of the preparation of substance and also the manufacturing company, and the composition and information on hazardous components can provide you the preliminary information. Then on point 3 and point 4, we have the identification of the dangers that are associated with the individual components and the first aid measures. This point number 4 is very important, especially if we need to provide a first aid to a worker. Then fire measures, accidental release measure. How can we manage any eventual release in the environment, for example? Handling storage, that is useful if you need to storage a very, very big amount of these chemical substances, for example. If there are some incompatibility, for example, with other chemicals, this is important. And the protection for workers to the exposure of these substances, chemical and physical properties, the stability and reactivity, the toxicological information. So if there are some limits for the exposition of the workers to this substance, ecological information, the disposal information, transportation, and regulatory information. And the last point can have more information, especially, for example, for the age statements and so on. So let's have a look to an example of a safety data sheets, especially to the most important part that we need to check. So section number 1, with the information about the substances, the identification of the chemical composition, the concentration, and so on. The second part is with the classification of the substance or mixture, and also the identification of the category, hazard class and category, and the hazard statement. And we can have just more information later. So here you can see which are the hazards that are involved with this substance. This is very, very important for verifying, especially the compliance with the regulation for the classification, labeling, and packaging. Then we have all the label elements, the label information that we need to check, for example. So in this case, you have the pictograms, you have the hazard statement that are, let's say, described and defined, not only the short form. So H2090 is defined as maybe corrosive to metals, and so on. You can have a list very long, it depends from the substance. Then also the precautionary statements, which are important for prevention of, let's say, possible risks for the workers. For example, in terms of the personal protective equipment, which kind of them you can use, or where you need to handle this substance, and so on. Then in section number 8, you have also the exposure control personal protection information. So for example, in this case, you can find the limit, if they are for this substance, for the workplace and for workers. And these are, I just define you in 5 minutes, these different types of limit for specific chemical components. So these limits need to be verified by measurements in field, and then you need to verify the compliance with the specific limit. Other limits that can be provided within the material safety data sheets for specific substances deal with the one defined by REACH regulation. And they are usually lower than the limit defined from the safety experts. And also this one needs to be verified to be sure that no effect level can be comply with. In the classification, labeling, and packaging regulation, you can find all the H statement, hazard statement, which define the hazard that you can be in front of for the manipulation, for the usage, and so on of specific substances. You can find all the list in internet. I provide you here this link with the PDF poster that you can print. You can put in the wall near your storage room, for example, with all the chemicals and so on, just to be sure that you have very clear all these definition and statements. And also for the precautionary statement. These are, as I said, some suggestion, strongly suggestion for the manipulation, for example, of several chemical, and all the information what to do if there are some accidents, for example, or some other events that need specific precautionary attention. And so, as I said before, we have a specific limit for each chemical agent that are defined as a threshold limit value. We can have them at European level, international level from the American Conference of Governmental Industrial Hygienists, and also for national level, specific national laws or contract of works, something like this. Also, for example, for Hygiene Institute, National Hygiene Institute, you can have defined a specific limit. Mainly, as we saw in the previous material safety data sheets, we have 3 different types of threshold limit value. The first one is the threshold limit value time-weighted average. This is a limit that we need to verify and to comply with for an average exposure on the basis of 8 hours per day, 4 hours per week of working activity. The second one is the short-term exposure limit. This is a limit that is used for example, 15 minutes of measurement. So for short time process, for short time activity, and this is the limit that we should not be exceeded at any time during a work day for the time weighted average, but for a short time we can, let's say, exceed, but only for this short, very short time. And then the ceiling limit, which is the absolute exposure limit that should not be exceeded at any time. So mainly, just to go back a bit faster to the previous material safety data sheet, here you can see all these limits. For example, the ceiling is not present, but for this substance, hydrogen chloride, but we can find if any other reference regulation can provide it, and we can have the limit in the material safety data sheet. So going on, what does they mean? Does this limit mean for the workplaces? This limit and compliance with this limit does not exclude the existence of the risks and also the need for intervention, so for the improvement of the working conditions. These are only reference. We can have information about, let's say, the level that we have not to go over, but usually, and for safer condition, usually we can use as more stringent limit 50% of the value that are provided in as a limit for the specific substance, or 10% of this limit, just to guarantee the health and the safety of all the workers. This is important to take into account since we need to be sure that the workplaces are safe for the employer. Which are, so we are arrived at the top of this webinar, which are the different steps for the chemical risk assessment. First of all, we need to identify the hazard. So we need to have a list, exhaustive list, but with all the substances, the chemical substances and preparation that are in the laboratory that we use in the company. We need to review the processes to verify if any dangerous chemical agents could be developed during these processes. So that it's important, especially for the research project, to identify any possible different and dangerous chemical agents can be produced during this process. And then the classification of all the chemical agents that are in the lab with the hazardous statement. This is important to have the overall identification of the hazard. In this way, we can have a list of chemical agents, we can have a list of H statement, and we can do a preliminary assessment of all these risks, just for the presence and the usage of these chemical agents. And this is the first phase of the assessment. Then we can go on and define that if the nature and the entity of the chemical agents that are present in the company are not dangerous are not classified as hazardous for all the activity inside the company, the risk can be defined as low or irrelevant, depending from the amount, the possibility of manipulation in safe condition, and so on. This is not usually common, let's say, in a chemical laboratory or in a material laboratory where we have several kinds of chemical agents. So we needed to go on. We needed to go on to the second phase with the development of a more detailed risk assessment, also through environmental measurements, for example, for inhalation, for thermal exposure, or through a model or algorithms that can be available for the risk assessment. In this way, we can have a value, a concentration of this chemical substance in the air, in the workplace, and then we can check if it is compliant with the limit or not. Where we are lower than 10% of the threshold limit value or not. We are lower than 50% of the limit or not. And try to compare all the chemical agents with all their specific limits, depending also from the usage condition, storage condition, and so on, and verify this compliance with the regulation. Which are the variables that are to be considered, that need to be considered for the chemical risk assessment? First of all, the dangerous properties of the chemical substances. So from the material safety data sheet, all the information that we can collect, the hazardous statement, the symbols, all the safety information that we need, for example, for personal protection equipment, and so on. Then we needed to consider the concentration, the type, duration of the exposure by the measurement, make during the process, during the utilization of these chemical agents. And also we needed to consider, for example, if there are specific circumstances for of performance of the work, and the quantity in use, the comparison with the limit value, if there are effects on of the adopted preventive and protective measures. For example, if we need to wear a face mask, for example, the concentration in the air can be reduced for the workers during the process and the activity. And final, the health surveillance conclusion from the doctor that need to be, let's say, involved in this assessment, especially for the chemical risks. So, starting from the formula, where we can, here is, evaluate the risk, we need to provide several indexes for the severity and for the probability, taking into account that for the severity, we need to classify, for example, the explosive and highly inflammable chemical agents with the, let's say, highest value. That is, for example, 6 for our case. This is an example of a specific evaluation of chemical risk that we have here in my company. And then go down from 6 to 1 from the worst and chemical classified substance, from exclusive to not classified. which need to be considered as well. And also for the probability index, taking into account a very, very, very low amount that are used within the company, from 1 to 6 with a very high amount that can be used for the process. In this way, here we can evaluate the safety risks, for example, for specific hazardous chemical agents, and in particular, as I said, for safety. For the evaluation, we need to take into account also specific storage conditions, specific emergency systems that we can have in the company, also prevention system, and all these aspects can reduce the probability that an event can happen. But also for the severity, we need to take into account, for example, the prevention system and how long is the duration of the contact for these or the manipulation of these substances. And so we arrive finally to our matrix for the evaluation and classification of different scores of the risks for the safety aspects. So we start from 1 to 6, coming from the not classified to the explosive, and the score from 1 to 6 from low amount to very high amount. We find all the results from the matrix, and we can, let's say, group the results for different level of calculated risks from low to high risk. It's important to consider that if we obtain an high risk, for example, for specific substances, we need to reduce it. If we have low risk for many other substances, well, we can reduce as a score, but not as, let's say, judgment of the risk in the company. And also for the health aspects. Also in this case, we use the formula for the risks, and we give the index for the severity and for the probability. In this case, the severity index start from 6 for carcinogens or mutagens agents, and arrive to 1 for not classified chemical agents. So the substances that have not any threshold limit value from the regulation. For the probability index, we define 1 where we have no exposition, so the experimental value of exposure for the workers in the workplaces is lower than, for example, the detection limit for the chemical analysis, and we increase the index arriving till 6 when we have an exposure higher than the threshold limit value. In this way, we can also have the matrix with all the results for the health risks, and also the range where we can classify the risk low, moderate, medium, and high, and so on. Also in this case, we needed to reduce these results by using, the best way to, let's say, reduce these results to pass from a moderate risk to the low one by, for example, eliminate the risk. So eliminate these substance that can be, for example, carcinogens or mutagen, and pass to I don't know, a toxic one, an harmful one, less dangerous substance.